Hi, this is a video on how to download the ISE design tools from Xilinx. The first step will be going to the Xilinx.com website. Once you're at the website, you want to click on the Downloads button located at the top. In the Download section, you want to select the ISE Design Tools tab. Make sure that you have the latest version selected. Then you want to scroll down till you see the ISE Design Suite. You want to go ahead and click on the Windows installer. Here you'll be prompted to either create an account or use your existing Xilinx account. If you decide to create an account, you want to make sure that you use your Texas Tech email address, as this will come in handy when we download our license files. Once you hit create an account, the download should start automatically. Remember that the download size is close to 6 gigabytes, so make sure you have a good internet connection and plenty of hard drive space. In the next part of this video, I'll show you how to download the license file for this software. Once you've downloaded the latest version of ISE Design Tools, the next step will be to generate a license file for that software. For this purpose, we will need to go to the Xilinx.com website. Under the support section, we will click on the Get License File option. You'll be prompted to log in again, so go ahead and log in with your newly created Xilinx ID. You'll see a list of products. The one we're interested in is the Vivado Design Suite license. This license file also includes a license for the ISE design tools. Once you select the license file, you want to click on the Generate Node Locked License button. And once you hit Next, the license file should be sent to your email address. Remember that you can only generate this license file a certain number of times. The next step will be the actual installation. In the next video, I'll show you how to install the ISE design tools and how to apply this license file towards your software. Once the download is complete, you will need to extract the setup folder from the .tar compressed archive. Once you've extracted the folder, you'll need to click on the setup.exe file. You need to accept the usual license agreements. Here, you'll need to select the ISE Webpack. You'll leave these as defaults. And you can select the folder where you want the Xilinx tools to be installed. Once you hit install, the setup process will start. Based on the speed of your computer, the setup will roughly take at least 30 minutes to install, so you'll need to be really patient. Once you've completed the setup, I'll show you how to add the license file to this software. Once you've completed the installation process, you'll be prompted to add a license file. In order to do this, you will need to go to your email address and download the license file from the Xilinx email. You will need to save this file under the licenses folder. You should be able to find this folder in your main Xilinx folder under Common. Once you've saved the license file in this folder, you want to open the license manager and click on the locate existing licenses. Once you hit next, you will see a list of licenses added based on the current license file that we just downloaded. Then you can go ahead and close the license manager and you should be able to use the Xilinx software without any problems. Alright guys, so in this video we'll be downloading the Digiland ADEPT software that we require to load our program file onto the Basys2 FPGA. So assuming you already have your ISE design tools and your Verilog code up and running, we will need to generate a UCF file which will then generate a program file that will be loading onto the Basys2 board. So in order to do this, you'll have to go to a digiland.com website, which is this one. And here under software, you will click on the ADEPT2 link. After you're on the ADEPT page, you'll download the ADEPT2 32/64-bit Windows version. Once the download is complete, you will run the setup file. It should be fairly quick. Okay, so the interface will look something like this. So, with regards to how to load the actual bit file onto the FPGA device, we'll talk about this more in the next video. So this is what the Basys2 board looks like. You have the main Xilinx chip at the center. You get user LEDs over here, along with the 7-segment 4-digit display. At the bottom, you get push button switches and some slider switches over here. You get this jumper over here, which you can use to change the default clock frequency. The default clock will be set at 50 MHz if this jumper is left open. You can select between 100 MHz and 25 MHz based on your preference. Along with these, you also get this jumper right here. This jumper, which is used to switch between PC and EEPROM mode. So if you write your code to the EEPROM that's on board the FPGA, you want to make sure that this jumper is set to EEPROM mode. That way your program will run no matter how it is connected. Even if it's connected off an independent power supply, your program should still run without any USB connection. Then we have the main USB programming port that's located here. This port is used to program the FPGA, and this is what you will use to as an interface between your Xilinx Verilog code and the FPGA. The slider switch here is used to turn on and off the board, and this jumper here
will be used to switch between battery powered mode and USB powered mode. So if you're trying to power your FPGA using a external battery pack, make sure you have a jumper connecting these two pins over here. These are the user GPIOs. So when you write your program and you write your UCF file, these will be the names of the ports that you would assign to your specific inputs and outputs. And also same goes for these switches. So make sure you note down these numbers here, as these will be the ones that you'll assign in your actual UCF file. Also make sure you know that this board runs off of a 3.3 volt supply. So all the voltages at these pins are 3.3 volts. So if you're trying to connect any other device that runs from a different voltage, you might need to connect a level shifting circuit to match the logic supply of the other external circuit. Also make sure you never connect a high power load to these pins. Always put a level shifting circuit in between them. In case of a motor, you want to connect the H bridge to the FPGA and not the motor directly. So make sure you keep these things in mind, and good luck with your programming.
Alright guys, so now that you have seen the introduction video to the FPGA board and you have some background on how Verilog works, let's go ahead and get started with the first program for the FPGA. So without wasting any time, I've already designed a small simple program to light an LED and turn it off. So this is the main program. So what this does is it's got a in for input or reset and the output that goes to the LED. I've also declared a register which stores the output value, and the output is directly taken from this register. I have a habit of doing this because if you have your output inside a loop or inside a if statement, Xilinx won't let you synthesize the code because it's a variable. So in that case, you need to add a register and then put that register in the loop. So what this does is inside the always block, if reset is 1, the output will be 0. So the output register is set to 0. So our LED output will be 0, so it won't turn on. And if the input is 1, then the output register is set to 1 and our LED output will be 1. And as a default case, I've just kept the output comes from out, which means the output will hold whatever value it has in case none of these conditions happen. So now since this code is synthesized, we can go ahead and create a UCF file for this code. And the UCF file is going to look something like this. Pretty simple. So we're going to declare the LED output from our module as location number M5, which you can see on the board. And our reset input and the in will come from A7 and M4, which are two push button switches. So what this means is the input values will be read off of these push button switches. So if the push button is pressed, it will give an output of high, and the high output will be considered as a input on this module. And once the output goes high, it will be given to M5, which is our LED, and it will turn on. So once you've done this, the next step will be the generation of the program file. So once your synthesis is done, you can just double click on generate programming file, and a bit file should be generated. Okay, so the bit file is now generated. Now we're gonna connect our Basys2 board to our USB connection and run the ADEP software. And in the software interface window, you should see the Basys2 board detected. So now what you're going to do is browse for your programming file, which is this one, the Basys2 t1.bit. So double click on this file. And the other thing to consider is if your jumper is on prom mode, to make sure you're programming the EEPROM on the FPGA. So this will mean that the program will stay in the FPGA EEPROM even though you disconnect the power supply and reconnect. So let's go ahead and program. Also, you need to remember that once you hit program on the EEPROM, whichever default program the FPGA used to have is going to be erased and the new program will be installed on it. So you might lose your initial program. Okay, so now the FPGA has been programmed, and in the next part of the video you'll see the actual code working on the FPGA.
Okay, so this is a simple program that basically writes a value of 1 into a register and sends it to one of these LEDs. And once I hit reset, the register is reset to 0 and the LED turns off. So let's get started and connect the power supply or the USB and turn on my board. And as you can see, none of the LEDs are on right now because the register that I write to starts off with a 0 value. So now let's go ahead and press, and as you can see, this LED just lit up. So that means that the register file has been written a value of 1 through this button. Now if I push the reset button, the LED should turn off. And on, off. And that's it. That's a really simple code.
Video, we're going to design a simple LED blinking code for the FPGA. So for that, we'll have to go to our ISE design suite, and I've already designed this simple little code that makes the LED blink. So how this code works is you get an input from the clock, reset, and reset. The clock is going to be the default 50 megahertz clock that we have on board, and the output will be given straight to the LED. I've declared an integer I, which I'm going to use as a counter. So what this is going to do is in the always block at the positive edge of the clock or positive edge of the reset, if I have reset, then my output register, which drives the LED, is going to reset to 0, and my integer is going to reset to 0 as well. Else, if the reset is not 1, the integer is going to keep on counting, which is declared in this condition, and it's going to increment by 1 for each clock tick. So basically it's going to increment to 50 million in case of this clock, because the pulse rate for this clock is going to be 50 million ticks per second. So the second if statement tells us that if the value of the integer exceeds 50 million, then the output will come from the negation of the output. So what this means is if the output was previously 1, then it will be the complement of that, which will be 0. If it was previously 0, then it will be the complement of that, which will be 1. And also, while doing this, the integer will also be reset to 0. So it'll start counting all over again once this condition is met. So what this means is it's kind of an infinite loop, and it will keep the LED blinking for an infinite amount of time, because it's going to keep on resetting to 0 and counting again. So the UCF file for this program is like so. My output is given to the M5 LED. The reset is given to the A7 push button switch, and my clock input will be taken from B8, which is the default M clock running at 50 MHz. So I will also show you how to generate a UCF file. So all you need to do is create a new source after you right click on your main top module, and then you click on the UCF implementation constraints file, and you can name it whatever you want, and that's how you create that. Also make sure that in your design properties you have the right chip selected for this project. So in this case, for the Basys2 board, you'll need the Spartan 3E family of FPGA selected. The device is XC3S100E, and the package is CP132. These details are available on the Digiland website and the Basys2 board manual. So make sure these things are selected before you go ahead and start programming. Okay, so now that the program is synthesized, I've got these check marks. We're gonna go ahead and generate the programming file, which in my case is already generated. So this file is usually generated in the main modules folder. So in my case, the folder is right here. So it will be generated as a .bit file. So you want to go ahead and select that file from your adept software and click program to program it to the PROM in this case. So that way I know that the code will stay in there even if I reset the FPGA. So let's go ahead and program this. And in the next part of the video, I'll show you how this program works on the FPGA, on the actual FPGA.
Okay, so my LED blink code has been loaded on the FPGA, and now let's go ahead and connect the USB connection and turn it on. Alright, and as you can see, the LED is blinking. I don't know if it's clear. Let's turn off the lights. So the code works, and let's try the reset. Yes, as soon as I push reset, it resets to 0 and starts off again. So what this is doing is it's turning on 50 million ticks, turning off again 50 million ticks. So the program is working, and this is how it should look. Now this program is very useful when you're trying to drive a motor, because in that case you're going to need a PWM signal, which is a pulse width modulated signal. And something like this will come in handy to generate a 50% duty cycle signal. So you'll have to play around a little bit with the values to get your desired duty cycles, but this is a good starting point for that. So I hope you enjoyed the videos and good luck with the programming.